today we're going to be talking about pattern matching. So without further ado, how do we do pattern matching and what is pattern matching? A given pattern it can be thought of as a data constructor. So for the example of the data type bool, we have false and we have true. We can think of the pattern being either true or the pattern being false. And we can then pattern match and do logic based on either of these cases. The first way we can pattern match on something is if we have a function f, which takes a bool. So we know it's going to take a pattern like this, of this data type, and it is going to, let's say, just give us back a string, which we're going to define. Then we're going to say that the first option is false, and that the second option is true. And I guess we'll just return it as a string like this, where we just give back the letter associated with that. Not really any good reason for that. We could also, of course, write this, maybe a more useful function, which is the not function. So I'll call this not prime, and this be not false is going to give us back a true, and not true is going to give us back a false. We obviously don't need to use the return keyword because there is no such thing as the return keyword in Haskell. We just need to write our expression. And our expression is very simple. It's just simply a value, which is the which is true or false here. So this is going to take a bool and return a bool. So why is it that this makes sense? And why are we pattern matching like this? It's because when we define our data type of bool, and maybe I'll call it booly so that we don't have any annoying compilation issues, but when we define it like this, we say that this data type has two different patterns that we can match on. And so in order to properly comprehensively pattern match on them, we need to have this function handle each and every case of booly. So for example, how would this change if we said somewhat true? We have this crazy type here, but we'd want to add to our functions somewhat true and I'll say an S here, and then not somewhat true is just going to be somewhat true, I suppose. I don't know what the not of that would be, or the negation of somewhat true is besides itself. And that would be how we continue to pattern match here. Of course, we want to have the our data type like this, so that we're not dealing with absolute chaos. For example, we don't even need to ever have no language ever needs to have the Boolean data type. We could have, for example, just simply the word of false and true to mean the same exact thing. However, when we use a data type, we are forcing that you must spell it like this exactly. This is really a string when you think about it. That's how I like to think about it. But it's a very exact string. Just to illustrate what I'm saying there, this is obviously kind of bad code, but yeah, that's the core of it. Moving on here, and that's always what we're doing here. The next pieces are more syntactical. So we could say instead that not double prime is going to say case x of true, then give false, and then case x of false, give true. So in this case, we're using a case statement to pattern match, yeah. Now, also, what about if this was further, instead, like the data or the maybe data type, where we have a maybe A and a just A and a false. Would we want to pattern match on simply just, or would we pattern match on A? in this case, we're going to want to pattern match on just A. So I'm going to have another function here, f m, and this is going to pattern match by saying that case x of just A. So we need to have the full pattern of that is defined by the data type in order to do logic with it. So maybe we print A, and then in the nothing case we also can pattern match on that, and we'll just print or put string line nothing. So yeah, that's pattern matching on that case, or pattern matching using a case statement. The last way in which we can do something is by using a guard. So a very simple example of this is let's say we have x here. We can ask, do the very equivalent thing of is just is a function, right? So we have this function is just, which I don't believe is imported. So I'll import it from data.maybe, and I'll see is just takes a maybe and gives us a bool. So I can say is just x, print or put string line just, and is nothing. Or I guess I could even just say not is just x. Oh, and I did that wrong. I'm just going to kind of even that out there. Put string line nothing. So obviously we use very simple logic here, but that is effectively pattern matching in a nutshell. Yeah, we can pattern match it on it in the simplest case by using the syntax here. We can also use case statements, and then we can also use guards to have more complex arbitrary logic, which needs to return a Boolean and then do some logic based off of that. We also have the kind of keyword of otherwise, which is literally just equal to true. So no matter what, that will evaluate, and we'll just say otherwise. And the last part to this is that, and this is kind of a bonus to what we talked about here, but we can also use a guard here to do some logic about just. So we can say that is A equal to 1. Let's assume that this is a integer we're taking in. And then it'll pattern match on that. So if we also were then to use a wildcard, everything else that does not fit our first case here of pattern matching on a just A, where specifically the A is equal to 1 and returns a Boolean of true, then print A. Otherwise, just simply print nothing. And so that's our first bite-sized Haskell. Went a little bit longer than 8 minutes, but I hope you enjoyed.